So let's see the steps like how neural networks started and everything, the process that involved with the neural networks. So neural network is also a branch, also is a subset of artificial intelligence. And when you talk about artificial intelligence, it's just you mostly see it being demonstrated by machines as opposed to a natural intelligence displayed by animals and including human beings. So many machines being able to do some tasks that require intelligence to do. And what this thing means is that it's about any system that perceives the environment. Because that's what AI is all about. They have to perceive its environment and takes actions that maximize a chance of achieving its goals. Any AI, any AI, any machine that we know, any AI, any machine that we know, it always works with a target. It always works with a target. Either an example is like if you should develop an AI that should be able to play chess, it targets being able to take a decision that will help him to yeah, that's what I join. Let me just admit then. Able to take decision that will increase the chance of winning the game. That will increase the chance of winning the game. So that's basically what this one is trying to say. So it needs to adapt to its environment and takes action that maximize a chance of achieving the goal. So humans always want more. Why do humans always want more? We have not been satisfied by mechanical or electronic machines such as planes sparking fires, pulleys lifting heavy rocks, and calculators. We want to automate more challenging and complex tasks like grouping similar photos, recognizing disease cells from healthy ones, and even putting up a decent game of chess. We already know when you go to the mechanical shops, we have even when you go to the port, we have pulleys that is able to pull down. We have pulleys that they can use to lift things from one side to the other side. So you have some machine that even help us to carry rocks too. And also have some electric device that go about to set fire to. Those are used to cook. I think the ladies know about it more. But we just don't want this mechanical type of machine. We just want something that's intelligent. Because those devices like the police, they don't learn anything about their environment. When you just put it comes or so in program that when you put something on the other side and you just put it up. You just push the other thing to the other side. But I want something more complex, something that can just understand its environment instead of always telling the device what to do. Imagine you have a machine that when they see the new, like at the port, a new container has been dropped maybe to the ground. The machine just go towards it and just goes towards it and just takes the container and maybe arrange it along with other ones. So that one will be an intelligent device. And the example they gave here is what we should be able to recognize photos. Recognizing photo is not an easy task. It's not an easy task at all. Like you have a lot of human beings in this world, and most of us we look a bit similar. If you're watching from a far away, you can see that most of us we look similar. So being able to write a computer program that's able to group similar photos together, recognize pictures, will be an easy task for us. But that's basically what we want to learn. We want to be able to classify images. And in this our neural network tutorial, we're doing you write a program or we learn how to be able to classify our own handwriting, like be able to classify handwriting numbers, like from 0 to 9, like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because it's not easy. But that's what we want to learn. able to program. So if you're able to learn how to even just be able to do classify these numbers, you can just move ahead and also do can move ahead and also do something for alphabet too. And if you think you're very good, I can even move ahead and just do for your photos too. In this tutorial, you're just going to learn the basics so that if you learn the basics well and you're moving ahead, it's become easier for you because that's the foundation that we build on. So human being always want to learn more, like what they're saying here. So when did AI become academic discipline? When did AI become very, very popular and very, very common? So so this what they said about AI. Say artificial intelligence was founded as an academic discipline in 1956. It's been a very long time, it in 1956, but it wasn't really common in our part of the world like Africa here. And it rose again in the early stages of 21st century, that's around 1991. So if it's around that time, it's not really been long there. So the 1970s saw a devastating economic challenge to the ambitions for AI. So when it rose into 10-1, before that time, I think around 1970s, people lost interest in it because it became an academic discipline around 1966. And when it reached around 1970s, people lost interest in it because they realized that they couldn't do much with AI, like what they're trying to, they couldn't do much with it because one can be about like model using the model, like as in the things that they want to use to classify this images or just to do something they want to do. Another part can also be about this the process of our machines that we're having back then. Well, as we're talking about now, no, our processor we have now is more it's 10 times faster than what we were having previously, like around those 1970s there. So it also affected them too. So most of them tried to withdraw. Most of the investors tried to withdraw, meaning they were taking their money back from projects involving AI. Then so it rose back again around 2000 and 2001. So as of now, because we have more advancements with AI as of now. People are doing a lot with it. Like when you talk about people are being able to, people have even done it, like created a robot. They all use this AI and machine learning stuff to be able to just do it. Because basically, AI is about being able to pursue your environment and take some action. And the action you're going to take is supposed to make you, the action you're going to take is supposed you know, to be based on a target, like what you're doing, will they achieve what they've set in front of you. So when you just see a normal robot, it acts more like a human being. That's more like a human being, being able to talk, be able to communicate, and reason with human being. No, that's a lot. That's a lot. People are doing a lot of stuff. So if you're able to learn this thing here, you yourself can just further it and you're trying to see if you can also do something else with it. When I had a chance to be taught by I think one of an AI things a specialist who he introduced me to I think neural networks. Introduced me to neural networks. He taught me a lot. So when I had this information to yes, so well, let me just try and also help others because what I know I don't really use it. I don't really use it. Maybe some of you can also you just advance on it and just use to do something else. Because you just want each and everyone to learn something. Okay, let's continue. So why we need a self-learning machine? Why do you need a self-learning machine? We see small organisms like bees become marveled by the different tasks they can execute. They can steer flight, adapt to wind, identify food and predators. We can't use our traditional cold hard black and white algorithms. Why? Because physical limitations present a fundamental roadblock to, however, increasing clock speed. Power density increases superlinearly with clock speed. Chips run the risk of melting once their clock speeds become high. So what this one just trying to say that I know a lot of you guys know how to program already. Anyone that programs stuff, when you ask someone to program something like let's say Most of our programming tasks is more about decisions. It's more about decision. You are creating a school management system. If you want to take someone is owing fees or not owing fees, you have to make decision. You have to compare it to the fees they're supposed to pay, what they've paid or what they haven't paid. And just when you see it's not up to, I just have to make a decision. If it's less than this, I just print this. If it's greater than I just print this. So that's what they're saying. It's a cold hard black and white algorithm. See, anything that like they won't say someone is in the school, someone is in the school, someone written exams, someone's not written exams. So you need to make a lot of decisions. And that's not really favorable. But with anything that can self-learn by itself, when it's able to just go through all the data, I can just decide, I just group those who have paid, who have experienced, who have paid and who have been paid, those who have written exams, who have not written exams. So that's what we want. We just don't want to code it in the hard way. Because we can't code everything. Imagine like if they were about to code this, they were writing a program for this robot, and we're just doing this manual way. Like if someone if the person speaks while you respond, I'm good. Can you just imagine if you understand program, can you just imagine the number of code the person is going to write? That'll be a lot of code for even the AI to even to just work. See. But then here again, we just want to write a code. That'll be able to do all those stuff just once. And even if you're doing it just once, it's still learning new stuff. It's still learning new stuff. This is what they call a general intelligence, being able to learn new stuff. Like you give birth to a child. While the child is growing up, he goes out with his friend, learn how to play basketball, learn how to play hockey, or learn how to play football. He didn't learn it in the house. He went outside and learned about it. So that's the same way our general intelligence is all about. We've not reached it yet. We've not reached it yet. But that's the ultimate aim of artificial intelligence, to be able to get a general intelligence. Friends, we have just specialized intelligence, like the chess, like the IBM chess. And IBM created a program, a chess program that was able to beat the then world best chess player. That's a specific AI. Like it's a domain specific. You can't take that the chess program to go and play football. You wouldn't even know what to do. So it's just domain specific, meaning it's only adheres to just one thing. Doesn't know everything. Just adheres to just one thing. So, okay, so how many minutes? Imagine like we have been asked how many. I just want you guys just take your time and do this calculation for me. Just don't use calculator or any phone or anything. Just watch it. Just try to do a calculation in your brain. Or the number say 270 124 80 183 204 456. Try and add it for me. Add everything and just give me an answer. So anyone can if you're ready, can give me an answer. But don't use calculator or your phone. Add the numbers on the screen for me. Someone said 1317. Someone said 2037. Wow. Like I think we waited for almost like 2 minutes and above, and we are still getting different answers. And see, when if you should input this thing in a calculator, the calculator is going to give us an answer straight forward. But when you try to use your own brain to do it, you see how you are struggling to do it. Okay, I think 1317 is correct. But see the number of times, if yourself see yourself, how many minutes did it take you for you to be able to calculate this? It took us a lot of time. But let's see this one too. Let's try and identify the images here. Let's try unlimited images. So you can see that straight for you can see that what the first one is a human being or face of humans. The second one is a cat, and the third one is a tree. Third one is a tree. So this one is just straight through. We just did it very fast. You see how we to use our intelligence to do it. The previous one, we struggled, but this one was easy for us. So you can see that with the previous one, it's easy for computers to do it, or machines to do it, but with this one, it's difficult for machines to do it. But it's easy for human beings to do it. But that's what we also want to learn. How were we able to how were we able to identify these images very, very easily like that? So that's the same idea we want to use to transfer it to the computer. That when you see images like this, are you able to classify them? All right, so let's see what we can do. So we're going to do with numbers. So streaming music, watching videos, and using calculators all deal with numbers. Constructing video frame from the ones and zeros is done using arithmetic. Adding numbers quickly may be impressive, but it isn't artificial intelligence. It simply requires an ability to follow very basic instructions, and this is what the electronics inside the computer does. So what you're basically trying to do here, so what you're trying to do here is what they're just trying to say is that we can't do away with numbers. We can't do away with numbers. Anything they're going to do involves numbers, so we just have to make numbers be part of us. So it won't be a difficult math we'll be doing. It's just our basic math we'll be doing. So, because they say even watching videos, streaming is all those with numbers. If there's time here, I could have just I can just write any image for you. Our handwritten information, I can just write an image for you. And I'll convert everything to pixels for you. You can see all the pixels are in numbers. Everything. They're all in numbers. So anything that we see, the videos, the images, everything, they're all in numbers. They're all in numbers. So that's the numbers that we want to manipulate. That's the numbers we want to just work our matrix on. They can help us to do our recognition very well. So now let's make numbers be part of it. I shouldn't be afraid of numbers. So before you continue, let's try down this file. That's what you'll be going to use. You have to download this file. So you have to download this file. I'll send a link. I'll send a link in the chat box so that everyone can just go and download it. Because that will be our data sets we'll be using. That will be our data set we'll be using. So it's better that you join the class using your better you join a class using your laptop. Better you join a class using your laptop than the phone. That's the first link I've sent in the group. If you see, just give me a thumbs up. If you've seen the link, just give me a thumbs up. All right, I think Hakeem have seen it. So you have to just click on that link or go to that link and just try and save the file there as a CSV file. As a CSV file. Right. So once you're downloading the file, let's try and continue with the tutorial. And let's see the application of AI. So adding numbers isn't difficult for computers, but identifying images is an incredible difficult task for computers to do. It is easy for humans to identify images. We suspect image recognition means human intelligence, something machines lack. But it is exactly these kinds of problems that we want computers to get better at solving because they are fast and don't get tired. So talking about some of the applications of AI is like we have the web search engines like Google. Google search engine is really marvelous. Is when you think about it, you really understand because you can search for sleep or can just search for a word like how, and the result they bring to you comes from almost like thousand. Yeah, you're seeing numbers on the site. Yeah, yes, that's the numbers that we need. You have to just right click it. All right, I'm coming. Let me just try and do it for you guys so everyone sees it. I'm coming in. So this is what you can do. Just come here, go to the link. Me, I've copied the link. I just put and I've displayed here. This is what I'm seeing. It's numbers because I need all these numbers to work with. And as I said earlier, even videos, music, and everything, they're all in numbers. These are images too. They're also in numbers. So in the next section, I'll just show you how to convert this some of the images to numbers. So when you come here, just right click here and just save it. So just save it. I'm using a Windows machine. You can see that with this Windows machine, the pop-up says that this is a Microsoft Excel comma separated value file. So in a simple sense, it says it's a CSV file. The CSV file. For me, if you like, I can just create a folder. I just create a folder here. If I just call it, let's say our MNext data. So you can just go to this MNext data and just save this file. What to this CSV file? Let's say you can just save it here. So you can just save this MNext file here. So that's it. It's the links there are two. One is test and one is training. You can apply the same idea for the training too. And apply the same idea for the training too. But did you guys see what I did? Did you guys see what I did? Did anyone see what I did? How I saved the file? Was it too fast? You can unmute yourself and talk. Okay, man of breakfast said he saw it. Okay, okay. They don't do so second. Sylvie said he saw it, so so our web search engine recommendation systems, understanding human speech, self-driving. Someone said, can I do it again? Wow. All right, so you don't worry, I'll just upload a video. When I'm done with this class, I'll upload a video on YouTube. And can just take your time and just go over the one Go over this, like the part that you don't understand. Okay. Country, I'm just managing my time here. I'm also a student. I'm also in the hostel, just trying to. I'm also trying to manage myself here. I'm also a student here, trying to manage my time between these two. So let's try. That's why it's very late. I know most of you guys also have something to do, or something else to do. But let's try to manage ourselves and just let's finish this tutorial. Okay, so let's continue. So the long term of AI is, as I said, is general intelligence, being able to do almost everything like how human beings used to act. That's general intelligence. So now let's see some differences here. Now let's see the difference between artificial intelligence and machine learning. Artificial intelligence and machine learning. The artificial intelligence is a technology that enables a machine to simulate human behavior. And machine learning is a subset of AI, which allows a machine to automatically learn from. So which allows a machine to automatically learn from past data without programming explicitly. So if you just watch this definition, we can see that machine learning is under artificial intelligence. Artificial intelligence is a broad, is a broad group, or it contains or any other thing. And machine learning is a subset of our AI. So anything that makes machine to just act, anything that makes machine to act like a human being can be classified as an AI. But machine learning is just a subset of it that uses past data. It uses past data to create a machine that can also learn. That is a subset of AI which allows a machine to that's a machine to automatically learn from past data without explicitly programming it. So it's better that we know these two differences. Machine learning is more about using data to be able to write machine that can learn by itself. But AI is going to encompass all those stuff. So you have some machines too that don't even use data. That don't even use data. Like that's someone's there. But they can still act like humans. But most of our machines that we have, they all use data on them. They all use things surrounding them or their immediate environment to make decisions. Let's see another differences too. You have data science and machine learning. So data science is a field about processes and systems to extract data from structured and semi-structured data. And machine learning is a field of study that gives computers the capability to learn without being explicitly programmed. So data science is more about making meaning out of data. When you give a data science data, you can just tell you, and more people that like imagine if it's a store, you gave a data science like a data from a store. It can tell you like the number of items that the people used to buy at the store, the time they used to come around and buy, and how they used to buy. Like if some people buy the items together, the data science can just tell you everything about it. It makes meaning out of data. But machine learning is more about creating a machine or a program that can learn by itself without specifically programming it to do. So one is more about being able to write models, like machine learning is being able to write models or algorithms that can make some that can use the data to make some decisions. The data science is more like a making meaning out of data, explaining our data to us, explaining our data to us. So data scientists don't know more about programming. A data science can be there, but he doesn't know how to program. He doesn't know how to program, but he know how to use some of the data softwares like We have a data software called R. We have another one called SPSS. Yes, these are some of the software that is very popular among data scientists. But a machine learner knows how to program. Someone that wants to be a machine learner should know how to program. At least, if not, he should know how to at least use Python or C. But Python is the common one because most of the packages are in Python. So you should know the difference. Most of the time, it confuses us a lot of time. Confuses a lot of time. So we have another one to call deep learning. And basically, what you'll be doing in this tutorial is more about it's more under deep learning. So deep learning is a subfield of machine learning. As I said, anything about machine learning is more about being able to create machine that uses sparse data. So anything that uses data to make decisions, any machine or program that uses sparse data to make decisions is under machine learning. So deep learning is a subfield of machine learning, and neural networks make up the backbone of deep learning algorithms. We'll be learning neural networks in this tutorial. In fact, it is the number of parts of neural networks that distinguishes a single neural network from a deep learning algorithm. So when like three or four, five or more of neural networks come together, they form a deep learning. So meaning a single neural network is just a basic or the basic foundation for deep learning. So if you understand the basic one, meaning you can understand the deep learning. When people be talking about deep learning, we see lots of diagrams, they will show lots of diagrams and stuff. It doesn't matter if you understand just the single one, meaning you can understand all the many or the ensemble neural networks. So deep learning is just like bringing two or three or four neural networks or more together. And it's also a subfield of machine learning. You can see, from the beginning, you realize that machine learning is an AI. And a machine learning is just something called deep learning. And the deep learning also like neural networks. Neural networks is more like the foundation or the basic one. So that's what they come to do here. We want to just do the basic one and use the basic one to do some handwritten recognition. And if you're good to go, you can just go ahead of it. Just learn more about it to do your own stuff too. And with here, with the recommendation system and all those stuff, they are different from neural networks. Mm. When you are doing the recommendation system and the models and stuff they use, it's a bit different from our neural networks. So you can't just use our neural networks and do recommendation systems. Can't use to do from more neural networks more about being able to do more about classification a bit, and it's something a bit of just predicting. Want to do some predictions, so I can use the neural networks to do it. But it's more about being able to do classification. But it can do a lot of stuff too. It can do a lot of stuff too, depending on how you use it. So that brings us to our main topic, our neural networks. Neural networks. What's neural network? A neural network is a series of algorithms that endeavors to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. So how we able to came up with neural network is we were able to just try to mimic how the human brain operates. So let's see how the human brain operates. So this is how the neurons in our brain looks like. This is how the neurons in our brain looks like. So I've seen it before, but this is how the human brain looks like. This part here, this part receives the signals. We see the signals, and then this signal just pass through this one, the synapse here. Then when you reach this part, just give it out as an output. No, I didn't want to just bother more about the names of it because we just want to see how it works. I want to see how it works. Yeah. Someone raise the hand. If someone raise the hand. Sometimes when I'm talking, I just shift slides. I just shift slides. So if you want to speak, I just unmute yourself and just speak like a classroom. So unmute yourself and just speak. You don't want to speak. So I saw someone raising the like. So this part, this part, this is are dendrites. Those that are familiar with this. These are dendrites. These are snaps, and these are our termites. So we see neurons are connected. We can connect more. You can connect more than one neuron together, and all of them are act the same way. They all receive information here. They all receive signals here. They process it here. They pass it through this lane here. Then they give out an output here. The reason they process it here is because if the signal they receive from this part is very small and it's already displacer, this place is not going to fire. Like the information they just want to pass to this one is very small. So it won't allow this part here to fire or meaning to send those information to other neurons. And this process is very, very important for us in this neuron because we should be able to also create a network that will, should be able to create a network that will be able to receive information here, process this information, and then when during this process of the information, we should be able to get a function that will determine if this signal is very high. If it's high, just pass it out. If it's very low, don't pass it out. Just leave it. Just leave it. Just give it an output of zero. So we use this same basic idea here to help us to create our neurons or our neural network. That's what they say. What? That's what they said. Well, our neural network is a series of algorithms that endeavors to recognize underlying relationships in a data to data through a process that mimics the way the human brain operates. That's the most important part is what the way the human brain operates. And that's how I explain it here. This is the basic way I can explain it to you, like how the neurons operate here. So as you've already, I think most of us have been able to install our Jupyter. If you're able to install that on corner, then you're free to go. You don't have to do anything else here. That's why I try to make you guys install it before we can start. If you don't install it, just go through the chat we had in the group and just see the process involved to install that on corner. As I said, I know there are some people here who have still not been able to install it. So the only thing I just do, I'm just trying to show my screen here. I'm just trying to share my screen. So what you can do here is just I'll just go to anaconda.com. So on a Windows machine like what I'm using here, this is what you see. It can change anytime. The interface can change anytime. So, but for me here, if I want to download, I just have to come down like this, and I see a download link here. A download link here. I'll just click on it. See, when I click on, you can see that down here it's trying to download it here. I'm already having it, so I'll just stop it. But if you don't have it, you can allow it to continue downloading. See, when I just click on download, it just what not downloading. When the downloads already, just like a normal Windows application installer, just click on the setup and just try install. And just try and install. So that's what you can do. That's how you can just install it. So this brings us to our first session. This is our first introduction to our neural network. If you are able to install a Jupyter notebook, we are good. And if you now you can we understand what neural networks are, we are good. And if you can differentiate between machine learning and AI, you are so good to go. So this is a basic introduction to our program I come to do. And when it come back on Wednesday, our next section will be on Wednesday. Our next session will be on Wednesday. When it come on back on Wednesday, we just start to delve into this neural networks. If you have any question, You can let me know. So Karim Abdul Karim, what's the question?
Yeah, okay. So I don't know. I wanted to ask how the learning is going to be. Is it are we gonna be working on a project, or as in through the learning, are we going to be going through, let's say, a particular project, or how is it going to be done? Yeah, thank you.
Yeah. So I'll first give you the idea of how you can, like the basic idea of neural networks. So when you're done, we just, as I said, you just take the data you downloaded. I asked you to download some two files. And there's the data you're going to work on. They're all handwritten numbers. So that's the data you're going to. That's the project you'll be working on. You all work on it together. Just see how we just start everything and just end everything. Which one? So work on the project. We just take it
Yeah,
together. We just do it here. Yeah, we do it here.
yeah. I think he's asking about. Said you have access to download some data or what?
Yeah, I sent a link. I sent a link.
For us
Check
to download something.
check the chat box. The chat box.
As in here or on WhatsApp?
The Google Meet. The Google Meet. There's a chat box in it. Chat box. I've sent the link in it. Okay, you know, I'll send a link to on WhatsApp so they can download. Those that are unable to download, they can also download it.
Okay.
Yeah, I added training data set too. I added training data set. You don't worry, I'll send both of the links to the group.
Okay.
They can have them and download it. Any other question? Any other question? So they don't see.
Yeah, please, good evening once again. And one question was,
Yeah, good evening.
is it going to be free as in free teaching is this, or you need to do
Is it?
something else, like a little community or something like that?
Oh, it's free. It's free. It's free. I'm not taking anything.
Or he will bless you. Thanks for that.
You're welcome. All right. So if there's no question, then this will bring us to the end of our first session. We'll meet again on Wednesday, the same time, 10:30 p.m.